Welcome back to the Phys Academy. Today we're going to take a look at gravity. No, not the 2013 film, but more specifically, Newton's universal law of gravitation. I'm your host JD, and let's get things started. First of all, what is gravity? Well, by definition, gravity is the force by which a planet or other body draws objects towards its center, and this is expressed by the symbol g, which has a value of 9.81 meters per second squared, as this is the acceleration due to gravity near the Earth's surface. How then do we hold an object against gravity? Quite simply, we just apply a force to it. For example, take your smartphone in your hand. To hold it out in front of you, you're going to have to apply some force to counter gravity. And to calculate this force, we can call upon our old friend Newton's second law of motion, where the resultant force is equal to mass times acceleration, or F equals ma. In this case, we know that the acceleration due to gravity is g is equal to 9.81 meters per second squared, which can be substituted into the equation for a, giving us F is equal to mg. Let's say your smartphone weighs 200 grams, which equates to 0.2 kilograms. The force required to hold it against gravity would be F is equal to 0.2 times 9.81, which gives us F is equal to 1.96 newtons. But taking a deeper look into gravity, we discover that mass and energy curve space, which makes two objects move towards one another. This is where we expand upon the second law of motion, and Newton's universal law of gravitation comes into play. Take the Earth and its moon as an example. Let's call the Earth mass 1 and the moon mass 2. Both have mass and energy, which we simply view as being the center of the objects, more commonly referred to as the center of gravity. From this, we can use the following equation to calculate the gravitational forces between the Earth and its moon. F is equal to g times by m1 times by m2 over r squared, where F is equal to the gravitational force in newtons, g is what we call the gravitational constant, which equates to 6.674 times 10 to the power of minus 11 meters cubed per kilogram second squared. M1 is equal to mass 1 in kilograms. Similarly, M2 is equal to mass 2 in kilograms. And R is the distance between the center of masses in meters. So let's try an example. Calculate the gravitational force in newtons between the Earth and its moon. So, we know that g is equal to 6.674 times 10 to the power of minus 11 meters cubed per kilogram second squared. In this scenario, we have the distance between the objects, r, is equal to 3.844 times 10 to the power of 8 meters. Mass of the Earth is given as 5.972 times 10 to the power of 24 kilograms. And the mass of the moon is given as 7.348 times 10 to the power of 22 kilograms. So, if we bring up the equation we previously learned, then taking the numbers from this example, we can simply input to give F is equals to 6.674 times 10 to the power of minus 11 times that by 5.972 times 10 to the power of 24 times by 7.348 times 10 to the power of 22 divided by 3.844 times 10 to the power of 8 squared. This should give you the answer of F is equal to 1.98 times 10 to the power of 20 newtons. And there you have it, Newton's universal law of gravitation in a simple way. As always, give the video a like and subscribe for more simple scientific content. I've been your host JD, and see you next time.